As AI becomes more powerful, it's likely to solve some of humanity's most difficult challenges. Because we're too slow at processing, we don't have the massive scales of data, or just areas where we shouldn't venture. But what if AI's goals are different? Let's talk AI alignment. The reason that we should care about artificial intelligence value alignment is pretty simple. The greatest chance at a bright future of coexisting with AI whose intelligence is growing at an exponential rate is if our values are aligned. Value alignment in artificial intelligence is where the AI attempts to do what we would want it to do. And this, what we would want it to do, may be slightly different from how the AI is trained. Stay tuned later for some wild examples where this is not aligned. Ultimately, intelligent machines are trained to seek and optimize a given value, so designing the reward or utility function or values are obviously important.
If you combine misalignment of values with a super intelligent machine that's very capable, then you have a really serious problem for the human race. So the point is that machines can and will make better decisions than humans, but only if their values are aligned with those of the human race.
I love some of these alignment problems. The first one that you'll probably know is King Midas. As Midas found joy and wealth in the power that he could touch and turn anything to gold, he soon beheld his food grow rigid and his drink harden into gold ice. Then he understood the value alignment problem. King Midas' example may sound far-fetched and trivial, but we're already seeing countless examples of this in AI already. Some hilarious, some just catastrophically bad. In my previous video of AI learning to play hide and seek, one discovered that it could get on top of a block and surf it over the barricades to seek the hiders. This ability is not envisioned by the programmers, but that didn't stop the AI from optimizing through that loophole. Check out this genius robot. This AI was tasked to learn how to walk with a minimum amount of contact between its feet and the ground. Yup, walking on your back with your feet in the air is one solution, I guess. This isn't cheating per se, but you can obviously tell that this is not what the programmers envisioned or were seeking. This example is one of my favorites. This is a simple game. The blue humanoid is trying to get across the line, and the red humanoid is trying to stop it. They seem pretty evenly matched until the red AI discovers a novel technique of just collapsing on itself and playing dead. And surprisingly, this yields outstanding results. In no real-world scenario would this tactic work, but the AI discovers optimal strategy. Sometimes AI behaves in very interesting ways, even when the human programmers think the incentives and goals are very well aligned. This, my friends, is AI alignment, or value alignment. How do we ensure that AI will make decisions in line with what we want instead of perhaps the easiest way for it to train? Moreover, how do we control something smarter than ourselves? You can't check every decision the AI is making, and even if you could, you probably wouldn't understand them. But you may be able to check the core set of principles that the AI relies on and make sure they're in line with our own. One famous example of these core principles are Asimov's law of robotics. These laws prevent the robot from injuring a person or itself. But what if a robot needs to make a difficult decision that humans have spent many thousands of years attempting to grasp? For example, autonomous cars are barreling down the road at 100 miles an hour when one car sees 4 people standing directly in its path. It can swerve, likely destroying itself and potentially the driver in it, you. Or maybe it ought to maintain its course while prioritizing its life and the human occupant. Is one life worth more than those 4 lives? Is there a difference between passively taking life and making a decision to actively take life? What if 4 people in the road were breaking the law by jaywalking in the first place? What if those 4 people were 85 years old? This dilemma is commonly referred to as the trolley problem, and it begs some very interesting questions. If we can't even align humanity on what one ought do, how do we propose aligning robots? Check out themoralmachine.net for examples of this self-driving trolley problem. It's pretty crazy. There are a lot of wicked smart thinkers working on value alignment right now, and this is a wicked problem. The odds are some future danger of AI doesn't come from some Terminator-style robot that wants to exterminate humans. It's more likely they're just trying to optimize whatever we originally asked them to do. Perhaps they take it just a little bit too literally, just like King Midas. That's why we'd rather have them optimized for what we want them to do. And if we get value alignment right, the robot may even want us to turn them off in dangerous cases. Here's 2 examples. In example number 1, Mickey's training an AI broomstick to carry buckets of water and then dump them into a cauldron for him. This scenario goes horribly awry when Mickey is drowning in the water that they continue to dump in the cauldron even after the broomsticks are underwater. These broomsticks are doing a great job at maximizing the reward function, not to Mickey's benefit. Example number 2, Mickey may generally train the broomsticks to help him do chores. They help him sweep, carry water, whatever Mickey wants them to do. Moreover, and this may be even more important than screwing up Mickey's chores, if the broomsticks did or was going to do something wrong, Broomstick 1 would actively fight Mickey if he was trying to turn off the broomstick. If Mickey turned off broomstick number 1, he wouldn't be able to keep filling that cauldron and optimize his reward. In example number 2, if Mickey turns off the broomstick, it's because he doesn't want it to do something dangerous. If Mickey went to turn the broomstick off because it was doing something wrong or dangerous, it would know that this is aligned with its value. The broomstick is trying to do what Mickey wants it to do, and therefore it may even stop knowing that Mickey's trying to turn it off because it knows that it's doing something wrong or about to do something wrong. That's AI alignment. There are obvious challenges and issues in AI alignment, and hopefully you have somewhat of an overview now. This is applicable now and not just in the remote future. When you are analyzing AI behavior, think about what it is trained to do. Was it trained to solve some complex puzzle, or was it taught to maximize a score? If it was taught to maximize that score, it probably found some way to optimize for that score that's a little bit different than actually solving the puzzle. This isn't cheating. This is optimizing a reward. And that's the way we train most of the advanced AIs today. If you're still here, that means you like these videos. Definitely hit the thumbs up button, hit that like, and subscribe so you can see more awesome content like this. This is a difficult problem and very important to solve. It will definitely be interesting to see how this work and research go in the future. This is Jerry. See ya!